So now, what are the examples of this non-hydrocarbon? We have something like C. We have something like CH3, COOH. We have CH3, CHO. We have CH3 and H2. So you see, this is non-hydrocarbons. It means that there are other atoms in this compound in addition to carbon and hydrogen. So look at it. This is ethanoic acids. This is ethanoic. This is ethanoic. This is ethanoic acids. Ethanoic acids. So you see there is oxygen. This is ethanol. Ethanol. You see there is oxygen also in addition. This is methane, because in this case they have imine functional group. So there is nitrogen in addition to carbon and hydrogen. So ladies and gentlemen, that is what we call non-hydrocarbons. It means that they have other atoms apart from carbon and hydrogen. So now we are going to look at hydrocarbon. Okay, Yusuf, it's like you are having question. You can ask. Unsaturated. Yusuf, is like you are having question. You have been raising your hand since. Do you have question?
No, sir, it's a mistake.
Okay. So we are now saying that we have saturated hydrocarbon and we have unsaturated hydrocarbon. So what is the difference between this saturated and unsaturated hydrocarbon? Saturated hydrocarbon are those compounds that doesn't have deficiency of any hydrogen. When you say they doesn't have deficiency of any hydrogen, it means that the carbon to carbon that are found in saturated hydrocarbon, they all have single bond. They all have single bonds. That means they are saturated. They don't need any additional atoms to attach to them. Then in the case of unsaturated hydrocarbons, it means that are those compounds that have deficiency of two or more hydrogen. They have deficiency, that is the lack. They lack two or more hydrogen atoms, and that is unsaturated hydrocarbon. So example of this unsaturated hydrocarbon is these two family, is alkene and alkyne. Alkyne have at least one or two triple bond, so it means that there is deficiency. Alkene also have deficiency of some hydrogen atoms, so that is why alkene and alkyne, they are example of unsaturated hydrocarbon. It means that they have deficiency of some hydrogen atoms. And then in the case of saturated hydrocarbon, examples of saturated hydrocarbon is alkane. Alkane. And the general formula for this alkane, the general formula for alkane is CN H2N plus 2. That is the general formula for alkane. And the general formula for alkene is CnH2n. And then alkyne also have a general formula, and the general formula for alkyne is CnH2n minus 2. So these are the general formula for alkane, alkene, and alkyne. So ladies and gentlemen, these are the classification of organic compounds. So now the next thing that we are going to start with, we are going to take alkane. 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 So as I said, alkanes, they have a general formula of CnH2n plus 2. So it means that if you have n, if your n is equal to 1, so you just take this value of 1 and substitute it in this formula. So you see you have Cn, so C1 H2 times 1 plus 2. So C times 1 is C. Then we have H. 2 times 1 is 2 plus 2. So we have 4. So we have CH4. So this is the example of alkane. And this one has a name called methane. And when N is equal to 2, then you are also going to substitute it in the formula. So you'll end up having C2 H2 times 2 plus 2. We have C2 2 times 2 4 plus 2 6. So we have C2 H6. So this is ethane. So from methane with 1 carbon, we have ethane with 2 carbon. And then the next thing is when we have N is equal to 3. So we have C3 H2 times 3 plus 2. Then we end up having C3 H2 times 2 times 2 6 plus 2. Here is 2 plus 2 is 8. So this is called propane. All these ones that I'm mentioning, it is very, very important you should know their name. So as the number of N, if N is equal to 4, we will end up having C4H10, and that is butane. And of course, for N equals to 5, we have C5H12, and that is pentane, from penta, pentane. Then we have C6H14. We have hexane, that is 6. Then we have C7H16, that is heptane. We have CH18. We have octane. Then we also have C9H20, and that is nonane. Then we have C20H22, that is decane. So this is actually the first 10 members of alkane. The first 10 members of alkane. So like for example, in the case where we have C4H10, that is butane. So if you want to draw the structure, you use something like this. The carbon are 4. So you see between all the carbon, you have single bond. And that is why they are considered, or they are called saturated. Here you have also hydrogen. So you see all this, you have hydrogen, you have hydrogen, and then you have hydrogen. So if you count, you have 1, 2, 3, 4. 4 carbon. You have 10 hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have C4H10, and that is for the butane. So if you look at it between all the carbon atoms, they have single bond. So that is saturated. But if you have double bond or triple bond in one or two of the carbon, that is when you have unsaturated hydrocarbon. So that is for the alkane. Do you have any question before we proceed? Is there any question?
No, sir.
Okay. So now the next thing that we are going to look at is some general properties of organic compounds. Or let me just say, before then, there are some terms that are associated with organic chemistry. Terms that are associated with organic chemistry. And these terms include isomerism, functional group, and homologous series. Homologous series is the series of the reaction in which each individual member of a particular family is differ from one another, or is differ by the consensus members by CH2. That is homologous series, is the series of a compound in which each member of that particular series, or in which each member of a particular family is differ by the next member by CH2. Like for example, remember we said we have CH3, so you have CH4 as methane, CH4, and then we have C2H6, then we have C3H8, we have C4H10. So what do you mean by the homologous series? Now between this and this, what is the difference? H6 minus H4. It means that we have C2. It's like you say 6 minus 4, you have 2. So we have H2. Then C2 minus C, we have C. So that is CH2. So it means that between this and this, they are differ by CH2. And then now let's look at this one. This is C3 minus C2, we have C. H8 minus H6, we have H2. So you see between the first and the second member, the difference is C2. Between that member and the second member, the difference is CH2. And of course, if you also take this one again, you will also going to obtain the same thing. C4 minus C3, we have C. Then H10 minus H8, we have CH2. So you see, in homologous series is the series of the reaction in which each member is differ by its next member by CH2. In the other way, you can simply say each member is differ by the next member by 14 gram per mole. By 14 gram per mole. 14 gram per mole. And how do you calculate this? 14 gram per mole is simple. What is the molar mass of this? The mass of carbon is 12. So you just say 12 times how many carbon? 1. Then plus H, the mass of hydrogen is 1. So we now open bracket and say 1 times 2, because it's 2. So 1 times 2. So 12 times 1, we have 12. Plus 1 times 2, we have 2, making 14 gram per mole. So it means that the molar mass of CH2 is 14 gram. So homologous series is the series in which each member is differed by the next member by 14 gram, and that is homologous series. That is homologous series is the series of the reaction in which each member of the family is differed by its next member by CH2 or 14 gram per mole, and that is homologous series. And then the next thing that we are going to look at is isomerism. Isomerism. What is isomerism? Isomerism is when you have a compound with the same, when you have a compound with the same molecular formula, but they have different structure. That is what you call homologous series. They have the same molecular formula but different structure. That is isomerism. It may be possible you can have compound with the same molecular formula but they have different structure. Like for example, you can have, let's say you have C4H10. This is, you can call this one N-butane. N-butane. That is normal butane. So if you want to draw the structure of N-butane, it's the same thing to say you have carbon to carbon, 4. Then you have hydrogen here. You have hydrogen. You have hydrogen also. All this throughout, you have hydrogen. But you can also have another structure of this something. Like for example, now we can have, let's say, C, but you can also have another C here. C, one hydrogen, another hydrogen here, and then another hydrogen here, and then we also have hydrogen here, hydrogen here, then hydrogen, another hydrogen here. So if you count all, you see that the number of carbon are the same. 1, 2, 3, 4 is 4. Then the hydrogen are 10, is still 10, but they have different structure. So that is what you call isomerism. It's a compound that their molecular formula is the same, CH4, CH10, but they have different structure. That is what you call homologous series. Is the series of the reaction in which each member of the series, isomerism are compound that have the same molecular formula but different structure. That is what you call isomerism. So ladies and gentlemen, I decide to stop here.